Uh-oh, dude, we're live, but I
Noise.
forgot to open my chat so I can see people talking to us.
Oh no. What are we going
I
to
don't
do?
know.
Hello and welcome,
Jen, why do you sound like a
everybody.
robot? I
I'm
don't
like
know,
a
it's probably my
robot.
headphones. You probably don't, actually. But let us know in the chat what we sound like, if we sound good, and if we're live. Um,
If I sound like a robot, let me know if you want it to change.
yeah, dude. I can't hear you, Kelsey Who
says.
can't you hear?
Yeah, can you hear Kip? Oh, never mind. My gotcha. Those darn Bluetooth.
Oh, okay. Hmm.
Dude, Kip, you know why it's
Dude,
called
why?
Bluetooth? I don't know. I was
I
wondering
don't
if
know.
you did. Like, as opposed to red tooth or green tooth or yellow tooth or any other color tooth.
Dude, I don't know. Um,
All right,
Alrighty,
Kip.
well, I guess we can start because I'm not sure who's all there out there in the world tonight, but we're here
Huh?
and we're going strong.
That's
Jen, I can't hear you at all. You're dead quiet now.
you can't hear me?
Now I can. You're back.
I don't know.
I don't know either.
Nothing changed on my end. So,
Yeah.
all right, well, everyone, I think it's about cool.
Cool, cool. So let's start by, well, I guess first things first. Remember, guys, donate if you feel like it. You know how to do it. It's down there. Go for it. But we don't got no pictures or anything to show you this time. So, yeah.
Just remember that cool
Yeah.
T-shirt and those cool
Just remember
stickers.
those.
But yeah,
Um, Alrighty. Well, Jane, we're going to start with a thought provoking question tonight. And that question
like
is,
always.
what is an image? We asked this question last time, but we're going to keep going with it. So
Yeah, we kind of rushed through it last time, so that's why we included it again. And also, we want to hear new thoughts because you've had a week to think about it. And Pip and I have
yeah,
had a
and
week
I know
to
you
think
guys
about it.
just have
And
been sitting
we
there thinking
are,
about it all week long. Like, what is an image?
yeah, true, true.
Um,
So yeah, let us know.
all right, no one wants to let us know, I guess. That's chill.
Pip, what is an image to you?
Um, Jaden, you're an image to me.
Oh.
Isn't that so sweet? It's light being refracted through a lens. Okay, well, that's one way that you can form an image.
Yeah,
I'm glad that sounds like someone paid attention to last.
and more big
Yeah,
fancy
that
words.
sounds like someone paid attention to last week, right? Um, but there's definitely other ways out there to form an image. An image is a picture of
Yeah.
something. That's good. We got that. That's cool. That's chill. Um,
Okay.
but Jaden, for me, an image is just the idea that you can some way, shape, or form, I guess, create light in such a way that it's clear, right? So that whatever's
It's
that's
yeah. It's kind of like except little puzzle pieces, and every single light ray is forming this puzzle to make, like you said, a clear image of something or a clear picture.
Yeah.
Yeah.
So an image is the idea that you can create light in such a way that it is clear. Awesome. I'm pretty sure you may have just
I like
repeated what I said, but that's cool. That's good. I'm glad. Yeah, I'm glad about that. Cool. So let's keep moving forward then, shall we?
Yeah.
Ooh, review. Jen, you want to review with us?
Yeah, let's say. So last time we talked about lenses and how light refracts through the lenses to a focal point, and that is what makes a clear picture, right? Without the lenses, we wouldn't have much of a camera. It would be kind of bad. You'll see later on the first camera ever, and you'll see why we want lenses and other cool technologies in the camera that we have today. Uh, then we talked about virtual images, and that is when the less than the focal point, right? So it gets to a focus less than the focal point, and the image is magnified, meaning looks bigger. Okay. And then real images is greater than the focal point and less than 2 times the focal point. So in that range, we get an image that is magnified, but it's a real image. And then also for real images, we have greater than 2 times the focal point, and the image is smaller. And that is what we like for the camera, because we need this big picture to fit on our little camera screen, and that's what we like. Okay.
Jen,
Anything
you
you
did
want
a
to add?
great job. Nice review. I'd give you a 5-star review, dude.
Dude, thanks.
So let's keep moving,
But
dude. Uh-oh, we already got a challenge
awesome.
question?
What?
How could that be?
Cool.
All right, so I'm going to hold up a
so
lens, okay? Jen, do you think they can see through that lens?
dude, I can see it, so I'm thinking they can. Hold it down just a little bit. Oh, to the right. Oh, left, I mean. A little to the right, just a tad. Right
Cool.
there.
So if they can see this,
Sure.
they might be able to tell that
Yes.
the image is flipped upside down. So the question is the image that's coming out of this lens right now, is it real or inverted? Here, we'll zoom in. There we go.
Virtual and oh, there you go. To the left, left, left. There you go. Hold
I was
steady.
getting tired.
So is that image of Kip a real or virtual image? Think about what we just talked about. We have a reel. Awesome. We have one reel.
Dude, so real. This is so
remember,
real, dude.
Yeah, and remember, you don't lose anything for answering the question, besides maybe some help, but that depends on the dice roll. But just answer the question. There's nothing to lose by answering it right or wrong. You have a 50% chance, or if you know it, 100% chance.
And if you guys notice, looking at Light's health, we're a little low right now, but you know, nothing too bad. But alrighty, so let's get moving on. We got two A's.
Got an A.
So so A is correct. It's a real image. Let's roll some dice. Do.
Good job, everybody.
Dude, we're back to 100 health finally.
Nice.
If I can find my way over to the health. Dude, here we go. Plus 7.
Sweet. So it doesn't matter if it was the min or the max, because either way we would get
Yep.
to 100. So good
Good
job,
job.
everybody,
So yeah,
answering
it's
that
definitely
question.
real. Remember, if it's an inverted image through a lens, then it's probably a real image. At least if it's a double convex lens like the one we have. All right, so that gets us to the next part of a camera, which is aperture. So if
Ooh.
we go ahead, Jen, I can't get my lens cap off. There we go. And if you guys can see, there's this little tiny hole inside that lens. That little tiny hole is called an aperture. So, what is an aperture and what is the purpose of it? So it affects the depth of field of an object, right? And
Uh-huh.
also it has to do with how sharp an object's going to end up looking. So the depth of field is whether or not an image, like the background, is blurry or in focus, right? And the example, so on a camera, if we look at this lens here again, hold on, I pop this lens off here. On a camera, you have, if you see here, there's these numbers that start at 2.8. You guys see that? I don't know if you can see that. And it works its way all the way up to 22. So those are your f-stops, they're called. And an f-stop is actually f divided by that number, so it's a confusing thing. The larger the number is, the smaller the hole. So that's just something.
You gotta think of it like a division problem. Divided by a bigger number gives you a
Yep.
smaller number, sort of
Awesome.
thing.
Yeah.
Yeah.
So, anyways, and the idea actually, if we move to the next slide here, the first ever cameras that were actually invented were these things called camera obscura, which actually I translates to a dark room. So before the onset of lenses, they were able to reproduce images simply by poking a hole into a wall, and it would create this inverted image similar to that of a lens. Now, if we look at this drawing here, I'll pull my laser pointer up so we can really get going here. You can see that this angle from this dude's hat comes down, down, down through the hole and then hits over here. And the same thing with his foot. It comes up and hits the foot over there. So it creates this. Why did they do this? Why did they do what? Create, I'm assuming, create these rooms. It was just a cool thing. It was, I'm not exactly sure why, but I think it's cool.
I wouldn't be surprised if they stumbled upon
Yeah,
it either.
and yeah,
like
they probably did. I accidentally stumbled on this once. I was sleeping in the back of my RV once, and there was this little tiny hole, like a rip in a gasket, up on top of it. And I was sitting there laying in my bed, and I was probably like 13, 14 years old. And I was laying there, and I looked up at the ceiling, and I could see the outside through the ceiling. I was like, what the? This is weird. And sure enough, it was this idea. So, this concept and understanding that if you did this, this would happen has existed for who knows how long. And if you've, I don't know, in some photography classes, you might even make one of these pinhole cameras for your first project or something, where you just poke a hole in a cardboard box and put some film in there, and you can actually take a picture that way. And so,
That's cool.
but how does it work? So, and this is why we asked that question again, what actually is an image? um, when you have light emanates out in every which direction, right? And so if you're trying to, if you just have a wall, that light from one point is going to spread out all over that wall. And so it's not going to create a clear image. So if you have a large hole, it's going to allow more of that light through, right? Like you can see over here on this side. But what happens when you start to make that hole smaller? Well, more of those light rays that were originally going in a similar direction are actually going to get blocked out. And so instead of having this spread of light, in this case, light's head being in multiple locations all over the wall so you can't distinguish it, now you only have one ray of light's head making it through. And so because of that, there's only one point on the wall that's going to have light's head, right? This is similar to, say, a lens, where instead of converging all of those rays to one point, now you only have a single or very few rays hitting a point. Gotcha. So that's pretty neat.
So are you saying with the light on the left where more rays are going through, you're not going to get a very good image, but on the other side, you're going to get a better image because there's only one light ray to focus on?
Exactly. So you could think of it, right, like this idea of, I don't know, like you're trying to throw a whole bunch of things, right? Or like you're splattering paint, let's say, against a wall, right? So you shoot a cannon of paint, and all that paint, if there's not a hole there, is going to splatter everywhere, right? But now if you have a little tiny hole and you're shooting that splatter of paint, the only paint that's going to go through the hole,
gonna look like a hole. Just
So now if you had all these different paints being fired at different angles, right, at different splatters, you could get a picture to form. Ooh, Jane, should we build a paint cannon and do this, dude?
That would actually be fun.
Donate so we can do it. If you donate enough money, we'll build the paint cannon. Just saying.
Yeah.
Okay, so Jane, we got another challenge question. Oh no.
Oh no.
Why does blocking light make something appear in focus? Oh, I guess we probably kind of already answered this, but
we kind of did. But if you are listening, you get a freebie. But if not, then you should be listening. So is it A, light bends toward the image sensor? B, light gets squeezed into a focus point? C, only a few rays of light get through, causing it to be in focus? Or D, light is alive and does whatever it feels like? Let us know in the comments. We have 1C.
Ooh. I'm going with D, dude. Light does whatever it wants.
You're going to say D? True. Seems like it. It seems like that's the case in particle physics.
Yeah, it is, dude.
C. We have two C's. Well, my heart wants to say D. Should we roll the dice, Kip? Well, I guess it's
no point. We're at full health, and the answer is C. So nice job. You guys are listening.
Yay-hoo! Woohoo!
Okay, so now we've got this picture, right? So this is the idea behind the lens versus the aperture, right? So if you remember, an aperture can help with shallow depth of field versus a deep depth of field. And the idea being, you can use the lens to focus in on the object that you want to be in focus the most, right? And so in the case of, let's say we wanted to have light focus, we could go ahead and put the lens so that it focuses light. But now we say, let's say we have this tree, this lovely tree that I drew behind it, and we want that to be in focus as well. So what do? Well, if we make the hole small enough, the aperture small enough, then we're only going to allow a few rays of light from that tree to get through.
Meaning it will be easier to focus.
So the tree will be in focus because only some of the rays of light went through. And light will be in focus because all the lights were, refracted to a single point. So now we have two ways of showing that, or to get things in focus in a single camera. So we have the lens and the aperture. Now let's say that we want light to be the only thing in focus and we don't want anything else to be in focus. Well, then what we can do is we can open that hole, right? And allow all that light from the tree to go through. And then
it'll just look like a big splatter, blurry mess.
Like the paint cannon that just got fired. But light will still be in focus. Yeah. Now the other important thing to understand about aperture is, we're closing this in. We're going to block out light. So that means that the image is going to be darker as well because there's not as much light going through the lens. So that's a trade-off between having a in-depth background, is that it's going to let less light through, so you're going to have to compensate for that in some other way. So here's a picture, some pictures that I took today, just real quick, to help you understand and see this depth of field in action. So in both pictures, this cherry right here is what I focused on.
Yeah, dude. Cherry tree.
So nice. In both these pictures, the cherry, it's the exact same focus. We have the tree in focus. But when we have a large hole, which is this f2.8, and again, it's dividing, and so that's why a smaller number means bigger hole.
Means bigger hole.
Because, and if you notice, the background here is extremely blurred. You can kind of make out some stuff going on back there, but you can't make out everything that's going on. But then on the right-hand side over here, you notice that the background is very much in focus. And that's because that hole is so small that it's blocking out most of that extra light coming through. So pretty cool. So you can get different effects for your photos, right? From this dealio. So that's pretty cool.
That is really cool. I just want to do a little shout out to how cool physics is and the people that actually experimented with this stuff and figured this out.
It is really cool. So, they claim, you can either be an artist or, you're either analytical or artistic. But, it's like when you really get down to it, like a camera is just a scientific instrument. So, whatever.
Yeah. Yeah, your photography class is actually just a lab
but
class.
They just don't teach you all the cool stuff we're teaching you now. Yeah. All right. So we got another challenge.
Another one.
Already, dude.
Holy cow.
Light wants to be the only thing traveling through the camera that should be, or traveling thing in focus as they travel through the camera. Okay. So should that be a large or small aperture? Do they want a large or small hole?
A or B?
Dude, what do you think? Dude, what?
Dude, I think it's C.
Dude, why is there a smoky
Medium.
background?
Is that what that is?
I guess.
Dude, it looks
Yeah,
like
dude,
an
why?
incense.
Just cuz?
Dude, I don't know what happened. I was just
B, go
searching
big or
something.
go home. Okay, we got two B's. And people are killing it tonight. That's all I'm going to say.
Yeah.
So we got another one right. Awesome. People are just killing it. So let's keep moving on. Alrighty. So let's move to diffraction. Diffraction? So there is a trade-off for having this hole. Alright? And this issue that occurs called diffraction. Now, as far as science is concerned, this is a really cool thing because it proves that light is a wave.
Yeah.
But it can cause some issues with photography. But as far as, anyways, from a physics standpoint, it's really cool. But the idea being, if you have this small hole, when a wave goes through that hole, after it passes through that hole, it's going to start radiating out in different directions again. And so, because of that, you can get these patterns of constructive and destructive interference. So if we remember way back to like lesson 1, I think it was, or maybe lesson 2, when we were talking about waves, and they have these wavelengths and they go woo woo woo, you can actually, dude, you remember?
Dude, I remember.
Wow, dude. Yeah. Do you remember how you could also add them together on top of each other? We kind of briefly went over that.
Yeah.
So if you have a wave that's going up, and at the same time you have a wave that's going down, if you add those together, they cancel each other out. Whoa.
Whoa. So that would be destructive
interference. And if they were all going woo woo on top of each other and you added those together, it'd make the peak bigger. Whoa. And that would cause...
So, okay, what you're describing right now, on the right-hand side, it looks like we have a wave there. And it looks like there's some peaks and then some at 0. And then we have this really big one and then some 0 and little ones.
Yeah, dude. Dude, that's what I'm talking about. Dude? So on this picture, you get these bright spots and you get these dark spots. But why is that, Jaden? Well, when the light goes through that hole, like I said, it starts to disperse. So all these different rays that go through start to disperse again when they come out the other side. And so if you look, this ray is going to come and hit this point here, and this one is as well. But the distance for those two to get to that point are actually going to be different distances, right? So they're not going to be the same. And because they're not going to be the same, they're actually going to be out of phase with each other. So those, those troughs and high points might be completely out of phase, or 180 degrees out of phase, or half a wavelength difference. And when that happens, you get this dark spot that appears. And then that wave radiates out again and creates another light spot where they all add up together, and so on and so forth. So you don't get this perfectly sharp image in the center like you would think, right? If you were to just shine a laser through a hole, you would think that you would just get a single dot on the wall, but you actually won't. You'll get something that looks like this. So even though you started out with a single beam, it will break up like this. And again, this is how waves interact when they go through a hole. And so this proves that light actually is a wave. So the important thing to understand about this equation on the right, that is just a little bit of maths, is that D stands for the diameter of the hole, and that lambda up top, that weird squiggly T thing, is the wavelength. And so the angle between the dark spot and the bright spot is divided by D. So the bigger the hole, the further out that dark spot is. The smaller the hole, or sorry, the bigger the hole, the closer together those dark spots are. The smaller the hole, the further apart those darks. Wait. No. What did I say? Okay, so yeah, smaller the hole, further apart the dark spots. Or this dot in the middle here is going to be wider. Okay. So yeah. Now let's keep moving, shall we? So why would this be useful though? So I said that in photography this might cause problems, but what would this actually be useful for? And the answer is something that's pretty special that I'm just going to go ahead and answer, unless Jaden wants to answer it.
Dude, let's think about it. We just talked about aperture. Then we talked about diffraction, and diffraction happens when waves go through slits or holes. So I'm thinking it's going to be because when light goes through the aperture, there's some diffraction happening. That's why I think it's going to be useful to know.
Good, dude. I agree. And it's going to affect our image, right? It's definitely going to.
Yeah, it is.
Because if you notice that there wasn't a point anymore on that wall, right? Like it was kind of like blurry and kind of. So that could be an issue. So it's good to know that.
Okay.
Another thing that has nothing to do with photography, Jaden, just in case you're wondering, that is pretty cool about diffraction is you get these things called diffraction patterns, like you see from this. And depending on different substances out there in the universe, they have different, they're made out of different, substances are made out of different things, and they actually emit different types of light. And so from that diffraction pattern, if you remember, there's that wavelength part of it. And so you get these patterns based on the wavelength. So you can tell which colors are coming off of that object. And you can actually figure out what that object is actually made of off of these diffraction patterns. So when people say, like, when you hear people say that the sun is mainly made out of like helium and hydrogen, and you're like, how do you know that? You've never been there.
Because of these really cool diffraction patterns.
Pretty cool. So you can actually figure out what a substance looks like without ever actually looking at it. So, alrighty. So what the picture we just showed on 2 slides ago was what happens if you have, it was like in one dimension, right? But our aperture isn't a single line, it's a round disc. So what happens to this diffraction pattern if it's circular? You get...
Well, tip just from looking at this
Yeah, dude.
airy disc. It's clear to me that the center is the brightest, probably going to be the most in focus, right? And as the rings go out and out, we just see that they get lighter and lighter and basically are black at the edge of the picture,
Yeah.
right? So that has to do with our waves, our diffraction patterns, right? Because most of it's focused at the center, it's focused less and less as it goes out, and eventually is a limit that goes to zero,
Right.
right?
Exactly. And you can see from this, we have this center bright spot, right? And this isn't just a single point anymore. It's kind of gotten these, like, it gets kind of blurrier and blurrier the further out you go, right? But then there's this dark
Uh-huh.
wall right there. And that dark wall, that's 100% destructive interference. But in between there's some form of constructive and destructive interference going on. So you get this bright spot. Um,
Uh-huh.
and so all of a sudden, your image that was in focus before it hit the aperture, now because of diffraction, is going to be slightly out of focus. And if you remember the bigger hole, that means that that circle is going to be smaller and smaller. Okay? So the bigger the hole, the less diffraction actually affects it. And so you get a more clear image of what is in focus from the lens, right? So if you focused on that cherry, then the cherry is going to be very much in focus. Now,
So this just sounds like you need a really good balance of the right aperture because of this diffraction, right? If you go too small, you're going to get a blurry image because diffraction. If you go too big, element of your picture is going to be in focus and everything else is going to be out of focus. So this is
yeah,
really
so
cool.
you have to pick and choose, right? This is when I guess the art comes into play at this point. You have to pick which
Yeah.
things you want. Do you want an object that's a little more blurry, but a background that's more in focus? Or do you want an object that's crystal clear, but then the background's going to have to be more blurry? That's the trade off. And that's just physics. There's not a lot you can do about it. So, Jaden,
Yeah.
what happens though? Oh, wait, we got a challenge question. Here we go. What?
What? Why do objects far away look like one object? For example, headlights when they are far away. Um, they focus to the same spot, making them hard to tell apart. Perspective makes them look like they are the same. Light is attracted to other light, so it bends towards other light. The airy disks are closer together, so they overlap.
Hmm.
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 I don't know, Jane.
Let us know what you think.
Let us know.
This is kind of a hard question, unless you were paying attention.
Well, we haven't given this answer yet, so, this one could be a little difficult. This one you gotta really use your noggin and think about. We got D.
Hmm. Hmm.
Hmm. So we got one D so far.
Have B.
Oh, we got a B.
We got a C, B, D. Oh my
We're getting
goodness.
all over the place, dude.
That's all right. This one's a harder question.
Okay. This is a hard question. Um,
Anyone get it right?
Dude, one person got it right.
Oh, and then we got an A. So somebody must have
Someone
gotten
got
it
it
right.
right.
We had every answer.
So let's roll the dice. Should we answer it now, or should we let the suspense linger?
Yeah, probably
Okay,
let
dude,
it
so let's
linger.
roll the dice. Here we go. Ooh. Oh, dude, they got a 20. I guess it was a hard question, though. So do we give them the 3? That's a reroll. That was a ridiculous. That was a little ridiculous, dude. So we got a 15 and a 14. Okay, so we'll take the 14. And then for us, ooh, dude, we got 2. And then we got +1, right? Because one person got it right. So that's minus 11. Ooh.
Yikes.
Ooh. All right. So the correct answer is D. So you have these diffraction patterns, right? And the further away you are, the more close objects become because of perspective and all these different deals like that, right? They become parallel lines coming in, whatever. And so you get this idea that things are closer together, and because of that, those two disks that form actually overlap each other. And so it makes an object from far away actually seem, or two objects seem like one.
Nice. I knew that.
Sure you did. So, there you go. So here's kind of a picture of it, right? So you got the two discs, and as they get closer and closer, they can overlap and become.
And they start looking like that one airy disk picture that we showing on the other side.
Pretty cool.
It's pretty cool.
So here's a picture that I took a while ago of the sun. And because the sun is so bright, you can actually see these diffraction patterns happening around the sun. So you got the sun here, and you kind of can see that there's this disk around it. And then if you move out here, there's a second disk that appears. And that is still caused from the sun, right? So you have this dark spot in between here. Woo! And then all of a sudden you have this other disk. And that ray of light, that circular ray of light, is actually the same light as what's coming from the center of the sun. So it's not, it's not just some weird image sensor thing because it can't handle the brightness. It's actually this diffraction happening. So it's not some weird computer thing or can't calculate it. That is actually what is going on. So that's pretty cool. Which leads us to our last thought-provoking question and our last slide of the night.
Yeah, name some apertures that are not part of the camera.
Yikes.
Yeah, I can think of 2.
2, dude?
Yeah. That's all.
Dude, I can think of, I mean, I guess we got to figure out how, like how specific we want to be, you know? Because I would say probably if you poked a hole in anything, you could call that an aperture. So.
Well, yeah. True. Oh, we got eyeballs. Yeah, that was my 2. My right eye and my left eye.
Wow, dude. So cool. So smart.
Yeah, we got pupils. Yes. That is, I guess, technically the aperture of the eyeball.
So that's that black circle in your eye, and it actually has the ability to have an f-stop, right? Because your pupils can get bigger and smaller. And so, and that's to help mainly to prevent light, right, from coming in too much, getting too bright of a picture. But it also works to help, because when you look at something, most stuff, right, from the human eye is in focus, and that's partly because your eyeball has an aperture. So that's useful. And it's why when it's darker out and your eyeballs get bigger, it's
They want more light.
Well, and it's harder to tell different things, right? Like more objects seem out of focus except for the one thing you're looking at because you have that depth of field problem going on. So
let us know if you have any questions. And if there aren't any questions, then Kip and I are done
we are.
for the night.
Next week we'll be going over mirrors, which is somewhat outdated in cameras. To some extent, a lot of cameras still use mirrors, but there's this whole fancy, new set of cameras like the one I've got right here that are mirrorless, and so you don't have a mirror anymore. But we're gonna still go with mirrors because mirrors are cool and we can learn more. And yeah, so and then after that we'll start learning about some quantum physics and the image sensor.
What?
So anyways, don't forget to hit that like button if you haven't done that already. Also subscribe. Yeah, mirror is greater than mirrorless. Oh, real quick thing, just so you guys know out there. One interesting side effect of diffraction as well is the fact that we have these camera sensors that are getting more and more megapixels packed into them, which means your pixel is getting smaller and smaller, which means that diffraction pattern is now showing up more so than it was before, because if you have a bigger pixel, then it's going to just land on that one pixel and you don't notice it. And so one of the ways to combat this is to use something like a full frame sensor, so you have a bigger sensor. Anyways, just a cool little thing. We'll talk about that probably a little more when we get into what a pixel actually is, and that'll be our last lesson of this show, so stick around. All right, thank you and good night, unless Jane wants to say something.